In this video, we are going to learn how to rationalize the denominator. Do you remember in 3rd grade, if you had the answer 4/8, they made you reduce that to 1/2? That was just a rule. You had to reduce. Remember in monomials, if I had m to the -3, a negative exponent, remember I had to move it to the denominator because I wanted my exponent to be positive? Well, we are a little particular about radicals too. We do not want radicals in the denominator. So I have to learn how to get rid of the radicals in the denominator, and we call that rationalizing the denominator. Well, just a little note. What is radical 3 times radical 3? Yep, you've got it. It's radical 9, which is just 3. What is radical 5 times radical 5? Yes, it's radical 25, which is just 5. So if I multiply the same radical, essentially this is radical 5 squared, and if I square a square root, they cancel each other out. So that's how we're going to work on rationalizing the denominator. One more little rule you should remember. Y'all do remember that any number over itself is just 1, correct? 2 over 2 is 1. X divided by x is 1. 3 divided by 3 is 1. I have 2 divided by radical 3. I need to rationalize the denominator. I cannot have a radical in the denominator. Do you believe I can multiply by 1 without changing this problem? Anything times 1 is itself. Do you also believe that any number divided by the same number is just 1? So 2 over radical 3 times 1 is not going to change it. But I also know that radical 3 over radical 3 is just 1. So I'm going to multiply 2 over radical 3. I'm going to multiply it times radical 3 over radical 3. Just multiply straight across. I will get 2 times radical 3 over. In the denominator, multiply straight across. Radical 3 times radical 3 is radical 9, which is just 3. Now remember, you cannot cancel these 3's because 1 is underneath the radical and 1 is not. If I have 5 over radical 6, I cannot have a radical in the denominator. I am going to multiply it times radical 6 over radical 6, which is just 1. So I'm not changing the problem. In the numerator, 5 times radical 6 is just 5 radical 6. In the denominator, radical 6 times radical 6 is radical 36, which is just 6. Once again, do not try to cancel these 6's. 1 is underneath the radical and 1 is not. 2 over 3 radical 5. I do not want that radical 5 in the denominator. The 3 is okay. The 3 is not underneath the radical. So, what do you think I'm going to multiply this by? You've got it. I'm going to multiply it by radical 5 over radical 5. Remember, that is just 1. We are not changing the problem. In the numerator, I have 2 times radical 5, which is just simply 2 radical 5. In the denominator, I have 3 times radical 5 times radical 5 is radical 25, which we know is just 5. So in the denominator, I will end up with 15. Can I cancel the 5 underneath the radical and the 15 that's not underneath the radical? No, you cannot. I'm going to do this problem 2 ways. You know how I love doing one problem 2 different ways. When you first see this problem, 7 over radical 8, maybe you are just so used to multiplying it by radical 8 over radical 8. Remember, radical 8 over radical 8 is just 1. In the numerator, 7 times radical 8 is 7 radical 8. In the denominator, radical 8 times radical 8 is radical 64, which is just 8. But you're not done. Do you see this radical 8? It has something perfect in it. You're not done. Radical 8 is the same thing as radical 4 times 2. Well, radical 4 is perfect. And when I bring it out from underneath the radical, it's perfect of 2. So in the numerator, I have 14, that 2 times 7, radical 2 over 8. I'm still not done because 8 and 14 can be reduced. 2 we're going to 14 7 times. 2 we're going to 8 4 times. Whew, okay, so my answer is 7 radical 2 over 4. Now, I cannot cancel this 2 and this 4 because of the radicals. I am finally done with that problem. But now I'm going to work it another way. Some of you may have thought, when you saw this 7 over radical 8, that you could simplify radical 8, and you were correct. Radical 8 is 4 times 2, so that would be 7 over. Radical 4 is perfect, so it comes out as 2. So I will get 7 over 2 radical 2. There's a problem here. I still have a radical in the denominator. This first 2 is not bothering me. This radical 2 is. Now, what am I going to multiply in order to get rid of this radical 2? You are correct. I'm going to multiply by radical 2 over radical 2. Once again, I know I've said this a million times now, but radical 2 over radical 2 is just 1. So I'm not changing the problem. In the numerator, I have 7 times radical 2, which will be 7 radical 2. In the denominator, I have the 2 out in front. But then I have radical 2 times radical 2, which is radical 4, but radical 4 is just 2. In the numerator, I have 7 radical 2. In the denominator, I have 2 times 2, which is 4. You know what I'm going to say. That's not magic. That is mathematics. One more problem to go. I have 3 over 7 minus radical 2. Do you see anything differently about this problem? Let's say we're going to try to get rid of this radical in the denominator. We know we're supposed to do that. So I'm going to multiply this times radical 2 over radical 2. But I do need to be careful because this is not a monomial. This is a binomial. It's 2 terms. So if I'm going to multiply by radical 2 in the denominator, I have to multiply both of them. Well, let's get to work. In the numerator, 3 times radical 2 is 3 radical 2. In the denominator, I have to use the distributive property. Radical 2 times 7, that would be 7 radical 2, minus radical 2 times radical 2, which is radical 4, which is just 2. Uh-oh. I still have a radical in the denominator. That was not the answer to my problem. Tune in to the next video if you have a binomial in the denominator that has a radical in it.